So if you imagine taking the simplest atom is a hydrogen atom. It's a proton in the middle, an electron going around the outside. And if we just think about the electron for a minute, special relativity tells us that because that electron has mass, it has energy. This is the most famous equation in physics, E equals mc squared. Mass is a form of energy. And we can convert different kinds of energy into mass and vice versa. So we can also think about visible light, like we see here. That visible light comes in the form of little particles that we call photons. But the energy in a visible photon is much less than the energy that an electron has in its mass. But if we go up to shorter wavelengths of light, ultraviolet, X-rays, we get to something that we call gamma rays, but they're really just light. If you take this big beefy photon and it's coming along with all this energy, if it hits, say, a nucleus of an atom and produce actually two particles with the mass of the electron. So one of them will be an electron with a negative charge, and one will be a particle that we call a positron with a positive charge. And they're always produced in these pairs. One is a particle and one is the antiparticle. So the electron is the antiparticle of the positron, and the positron is the antiparticle of the electron. Antimatter is really just another kind of particle that's there all the time in that simple picture. In that view, these things are all kind of equivalent. They're all sort of fundamental particles. They're produced equally. They have not identical properties, but they have these sort of mirror properties in a way. But when we come back to the universe that we live in, and not just the simple version, you look around and you say, okay, what do I see around me? Everything you see is made out of electrons. Everything you touch is atoms that are made out of electrons. And you say, well, where are the positrons? Because weren't they all produced at the same time? And that is a very profound question that we don't know the answer to. This is a great mystery in physics, is why is the universe, as far as we know, made almost entirely out of what we call ordinary matter? So one of the reasons to study antimatter, we think that it's going to tell us something very fundamental about the basic properties of the universe. This has always been the drive to understand the world we see around us.